Coevolution. The term can be broken up into parts that are easy to understand. Co means two or more things that are joint and mutual, in other words connected. Evolution is a species change over time due to natural selection. When we put everything together, coevolution is defined as two or more species reciprocally affecting each other's evolution. A prime example of coevolution was discovered in the 1950s along with 3 dead hunters in the Oregon wilderness. The 3 hunters had unknowingly been caught in the middle of a biological war that had been waging for 10,000 years. This cute little newt might look harmless, but it harbors one of the deadliest neurotoxins in the natural world, tetrodotoxin, or TTX for short. TTX is the same toxin found in the ocean's most poisonous creatures such as pufferfish, angelfish, the blue-ringed octopus, starfish, mud crabs, and many more. While collecting water for coffee from a nearby natural source, one of the hunters mistakenly scooped up the poisonous little reptile and boiled him into a deadly mixture. Within 17 minutes of ingesting TTX, the hunters suffered a vast array of symptoms before falling into a state of lucid paralysis that lasts anywhere between 20 minutes to 8 hours. In this coma-like state, thoughts are impaired, and convulsions and cardiac arrhythmia become fatal. What makes TTX so deadly is its ability to deplete the body of oxygen. TTX causes nerve cells to stop functioning completely, which results in paralysis so severe that you stop breathing. What researchers found most shocking was that the toxin from one little newt was enough to kill 3 adult men. What they didn't know is there is enough TTX in one newt to kill approximately 100 people. It only takes 1-2 milligrams of TTX to kill a person, which is equivalent to a grain of sugar. This begs the question, how did an 18-centimeter long newt evolve to be so deadly? The answer lies in nature's most fundamental mechanism, natural selection. To understand how the rough-skinned newt evolved the adaptation of TTX, we have to know why. One would assume that the newts do not have any natural predators because of their extraordinary toxin potency. However, what is equally as extraordinary is their main predator's toxin resistance. The Oregon garter snake can eat several newts at a time without suffering the effects of TTX. Both species evolved their adaptations because of the selection pressures imposed on one another over thousands of years. Essentially, the biotic environmental pressures gave both species an ultimatum: evolve or become extinct. The newts had to evolve an adaptation to their environmental pressure, which was predation by garter snakes. And so, over thousands of years, they became toxic, infused with high levels of tetrodotoxin that paralyzes and often kills predators that make the mistake of attacking. All but one, the Oregon garter snake. As the newts became toxic to adapt to the snake's predation, the snakes had to adapt resistance to the toxicity or become extinct due to toxin death and starvation because the newts are a central part of its diet. The arms race had begun. As the newts evolved higher levels of TTX, the snakes with lower TTX resistance would die, and those with higher TTX resistance would survive and reproduce. The genes of some offspring would mutate, giving them a higher resistance than their parents. This new generation of snakes would become so successful at hunting that the selection pressure would now be on the newts. As the snakes evolved higher levels of TTX resistance, the newts with lower levels of TTX would die, and those with higher levels of TTX would survive and reproduce. The genes of some offspring would mutate, giving them higher toxicity than their parents. This new generation of newts would become so successful at surviving predation that the selection pressure would now be on the snakes. And so on and so forth. Like a cycle of constantly one-upping each other, each species was competing to be more fit than the other. However, having the highest potency or highest resistance doesn't always make you the fittest. Having a lot of successful offspring does. To have a lot of successful offspring, energy distribution is key. Producing TTX and resistance to TTX takes energy. For newts and snakes, having biological weaponry is essential for survival. However, as the definition of fitness states, not only must they survive, they must reproduce. Newts and snakes that use too much energy on their biological weaponry don't have as much energy to reproduce and provide for their offspring, resulting in lower fitness even though they have better odds for survival. A well-rounded newt or snake with pretty good TTX levels or TTX resistance has a better chance of passing on its genes because it has just enough protection and energy to conceive and raise more offspring. A super newt or super snake with crazy high TTX levels or TTX resistance has a better chance of surviving, but its body is so tired from producing all that TTX that it doesn't have as much energy to conceive and raise offspring. Over many generations, both species evolved just enough to survive and reproduce due to evolutionary trade-offs that limit adaptations. Survival of the fittest also means survival of the most balanced. In conclusion, this example of coevolution shows us the complex processes behind natural phenomena. All adaptations of every organism alive is a result of biotic and abiotic pressures. Everything on Earth is connected in some way, and even the smallest pressure has tremendous impact over long periods of time. Slight increases in TTX over thousands of generations created one of the deadliest organisms in history. This example also helps to define what survival of the fittest really means. Nature favors efficiency, and although an organism is safer with adaptations that protect from predation, fitness is about being able to pass on genes to the next generation. This is why overpowered adaptations are so rare, because they are inefficient and detract the ability to conceive and raise offspring. More than anything, this case study shows us that natural selection has a tendency to create the fittest and most balanced organisms possible.